Dear learners, I am Lev, one of the educators of the SHEET program, and after my fellow colleague Madeline introduced you to the function of a heat engine, I will show you how we humans use this technology for our all-day life. So what you are going to look at right now is how we humans use something theoretical and actually adjust it to our all-day life, to something very practical. What you see right here is an animation of a thermal power station from the inside. So let's start from the absolute beginning to understand how this thing actually works. The first thing we will need is H2O, or water, which is also the most essential, or one of the most essential resources we have got on planet Earth. And you'll see in a minute why this is also essential for generating electricity with a thermal power station. On the bottom's slight left middle of the animation, you can see a plus sign moving to the left, surrounded by tubes. This is called a pump, which accelerates or pushes the water into this container, which I'm going to talk about right now. Now let's have a look inside this container, which is nothing else than a gigantic oven, actually. This oven, as I call it, can be heated in many different ways, respectively with many different kinds of resources for it to burn. In this case, it is heated up by nuclear fission, which is an optional process of applying heat onto the water that we need for our steam engine or our thermal power station right now. However, let's get back to our general overview of the thermal power station. So in there is something orange that is moving and the blue thing within this gigantic oven, or containment structure as it is called in this diagram. And both have different functions, or better said, duties. The orange structure is the part that heats up the water, whereas the blue structure is there to contain the water, which is now evaporating into steam because of the heat of our yellow, orange, red structure. The funnel-like shape of the top of this container compresses the steam, which also gives it a little bit of extra acceleration to it. Now, this steam is so powerful that it can rotate a gigantic stainless steel turbine. Lastly, the turbine rotates the generator, which induces electricity and is connected to a conductor which provides entire cities with electricity. This is how we provide cities like Berlin, for example, with electricity. But with the knowledge that I've given to you until now, this electricity would not last long, because I still want to tell you a very major and important feature of our modern thermal power station that makes it possible for a city to have almost constant electricity supply. After the steam has powered the turbine, there is an opening for the steam leading to another tube so that this container where the turbine is inside will not explode because of the pressure of the steam. This tube leads to another structure, the so-called condenser, which consists out of another container with a heating that circulates cold tap water so that the steam can turn into liquid water again. Finally, the liquid water gets sucked up by the pump in the middle again, and the circle starts from beginning. This very efficient cycle is called the Rankine cycle. It is an important step in engineering and very, very important for our modern society. Oh, you're asking what I'm doing right here? Basically, I'm generating electricity. I'm holding a mini power station in my hands. Only that this power station is not powered by heat or any other form of energy. Well, it is. It is generated, or it is powered by my muscles, my arm muscles. Now, enough for today. My next video is going to be about 10 major forms of energy. And thank you very much for watching this chic education video with Lev. Goodbye.